Hello. In our previous lecture, we have discussed about the certain things we have to consider when we use TLS protocol. So that's about uh, outdated algorithms and certain key sizes and possible attacks and possible other tools like compression kind of things, and what are the impacts of those things when we use them. So, as a security engineer, you have to consider all these aspects and then decide what sort of algorithms you have to use and what are the sizes of the keys and uh, and how these algorithms to be used in your servers. So today we are going to discuss about how to use TLS protocol suite on a web server. So there are mainly three things to be done. The first thing is we need to generate a public and private key pair and get the public key signed from a trusted certification authority, which is a trusted third party. And the second thing we have to do is once we get that certificate, we have to configure our web server to use that certificate, which is signed by a trusted certification authority. And the third thing is we have to uh, configure our web pages to load all its resources over this TLS security protocol suite. Resources means images, style files, JavaScripts, and other external scripts. So when we get the certificate, the first thing we have to do is from the server's side, the server who is going to establish that TLS protocol suite, they have to, the server's admin, those kind of people, from the server side, they have to generate an RSA key pair. So importantly, this key generation should be done by the server side. And then keep that private key or that secret key to himself, to the servers, and the public key will be sent to the certification authority to get it certified by the certification authority. So this key generation, not that it is very importantly, it should be done by that server side. So we can generate an RSA key pair defining a key size that can be 2048 or 5012 bits long key size. Anyway, once we generate that key pair, we have to generate a certificate sign-in request CSR file that includes that public key and also the domain name of that server. And that request will be sent to the certification authority. That is a request to sign our certificate from that certification authority. So that contains a public key and the name of your domain you want to get the certificate. So that those are the two main things should be included in a CSR or the certificate signing request. So send this CSR to certification authority who will perform some validation and they will probably get some charge for signing a certificate, and also they might need some paper documents, business information, that sort of things, and do some validation, and then they will do that domain validation and extended validation and do the sign-in thing for that particular CSR request, certificate sign-in request. So mainly it includes the public key and also the domain name, and also that can include other things like owner's name, address, and sub-organizations, that sort of other information. And then this certificate will be signed and sent to your site, and then you have to establish that certificate in your server. So need to install your certificate, the certificate you get from the certification authority, along with the intermediate certificates of your certificate authority, so that browsers can verify the chain from your certificate to a trusted root. Generally, these trusted root certificates are uh, by default given to your uh, clients' machines from their OS or from the web browsers or other softwares they use. They are in the machines from that production time. They have the trusted roots, and once you get the certificate, once that particular server gets a certificate signed from a trusted authority will sign that certificate, and if there are other intermediate certificates, they will send that certificates to the particular server, and server has to provide its certificate and also intermediate certificates in a way that server certificate will be verified through the intermediate certificates, and finally uh, coming to that trusted root certificate. Since that trusted root certificates is trusted by all the clients and everybody, they can build up the trusted chain up to the server certificate. And need to say which directory should be protected by TLS. So that sort of information you have to give when you configure the TLS server in your server. And need to say which cipher suits to prefer enable forward secrecy. So you have to define what are the cipher suits you are going to use in your web server. So then based on that, cipher suit will be negotiated with the client. So as a security engineer, you have to choose these set of cipher suits based on your knowledge about uh, the recent advances of cryptography. That means what are the outdated algorithms. You have to note that, and you have to use all the valid and standardized algorithms at that time. And also you have to choose the key sizes in a way that they are unable to break at that moment. So older days there can be shorter key sizes, but nowadays they can be vulnerable to several attacks. And also you have to, as a security engineer, you have to decide and what are the other algorithms you, whether you use data compression or not. That sort of decisions you have to take based on your knowledge and current trends in the cryptography. Okay. For a practice, I have in my previous slides, previous lectures, I have given a link to some tutorial about the certification authority. So there you can try several Linux commands, how to generate key pair and how to generate the CSR file, and once it is sent to the trusted certificate authority, how the certificate is generated for that purpose, what are the uh, Linux commands to be used. That sort of information is in that tutorial. I will again provide the link so you can try that and get some knowledge about how these things are happening in reality. Okay, so now we know that we have to uh, generate a key pair, and then we have to generate a certificate sign-in request including that public key and the domain name, and that should be sent to the certification authority to get it signed by the certification authority. So once we get that certificate, we have to configure that certificate with our web server. Then we can provide the necessary uh, secure services to our clients as a web server. Okay. So there are several things you have to consider when you configure a web page to use TLS. And previously we discussed about the things you have to consider when you use TLS. as a security engineer. Now you uh, get the certificate and everything, you configure that, and you choose a cipher suite and everything. Now you have to consider several other things when you configure the web page to use TLS. So you have to specify web pages load uh, resources. So that means if the page is loaded over TLS protocol but not the JavaScript, then an attacker can just replace the JavaScript or inject something to the JavaScript and have their own code executed in the client's browsers. So everything like the web page, the HTML content and JavaScript and images, style files and everything should be loaded through the uh, TLS secure channel. Otherwise, some part will go from the server to the client using the secure channel, and some other parts can go without the secure channel. That means an attacker can inject something to that and do some malicious things. And also, uh, as a security engineer, you have to specify which pages should be protected by TLS. Just the login page, or login page plus all the pages after that, and or maybe all the pages. So depending on your requirement, you have to specify what are the things you have to protect. You have to protect. And also the Google starting to use HTTPS as a ranking signal that you use secure channel, that means TLS protocol to for your data transmission, and making sure HTTPS is used. So once you have set up HTTPS in your server, how do you ensure people actually use it? So you might have as a server, you might have set up this secure channel, but you have to uh, force your clients to use that instead of just using that HTTP, or that just a HTTP protocol. So if a user types in an address or follow a link, it might first request non-HTTP version. So sometimes if the client requests a non-HTTP version, that will send the request to the server as a non-HTTP, and server will act like a non-HTTP way to respond to those requests. So as a user, you have to install HTTPS everywhere extensions. So whenever you type something in your address bar, it defaultly use the HTTPS address. That means it will go through the security protocol suite. So well-known site automatically rewrites this. Otherwise, some sites, not well-known ones or not properly designed ones, if they request through non-HTTP, it will go with non-HTTP. If it is requested with HTTP, it will go with HTTPS. So likewise, so as a security engineer, you have to specify if the request is typed as a non-HTTP, it should rewrite as HTTP request and sent as a secure request. As a web server administrator, enable HTTP strict transport security. That means whenever non-HTTP thing is request is sent, the server will only reply through HTTPS. That means through the secure channel. So that sort of things you have to consider when you configure the security protocol to use in your web servers and support or serve your clients. And what TLS certificates can do and cannot do. There are certain things that certificate can do and cannot do. They can do that, they can provide assurance that the server is who it says it is. Assume the certification authority is honest. So we know that root certificate of certification authorities are provided to all the machines, all the devices at their production time. So everybody is going to trust that root certificate authority, the certificate authority. Their root certificate is trusted. So based on that trust, the certificate provides an assurance that server is who it says it is, not another person. So different levels of assurance depending on different levels of validation, like domain validation or extended validation, but this is mainly the what the certificate does. It gives an assurance to the identity of the server. And what are the things it cannot do? Prevent website vulnerabilities. Certificate can't do that. For example, cross-site scripting attacks, SQL injection, that sort of thing. Certificate cannot eliminate those attacks and indicate that the website has been validated by third-party auditor. So that sort of thing certificate cannot do. So they cannot simply prevent the vulnerabilities. They can't prevent the like they can't mitigate the attacks. So those things will be done by the algorithms uh, used for data transmission. Certificate is just give assurance about the public private key pair and the identity of the server to the client. And based on the algorithms used in the data transmission and powerfulness of those algorithms and strength of all those algorithms, based on that, the entire security will be um, depending. And what can a malicious certificate authority do? So malicious certificate authority. The web server never gives its private key to the certificate authority. I mentioned that certificate authorities, sorry, the server's public and private key pair is generated by the server side, and only the public key is given to get it certified, not the secret key, not the private key. So the certificate authority cannot decrypt traffic between web server and its client, because certificate authority doesn't know the secret key. Sometimes we can expect a malicious certificate authorities, they can say like they generate the key pair and give the certificate and secret key to us, to the server. In that case, certificate authority has the private key of that server, and then uh, can decrypt or sign or anything that can be done by the server side. A malicious certificate authority could impersonate any server by issuing a fraudulent certificate, and it is hard to detect, no way of knowing if the certificate was honestly issued or not. And a new initiative called Certificate Transparency tries to monitor all certificate issued to watch out for fraud. So malicious certificate authority can impersonate any server. So impersonate any server and try to act like that server and issue some invalid, like illegal certificate, but in that certificate the certificate authority has the private key for that particular certificate, and then try to impersonate like a certificate authority, sorry, impersonate like a server, and try to decrypt and sign the messages likewise. So that's the only thing that certificate authority, a malicious certificate authority do, but we have to have a clear understanding about how these certificate authorities work, and then we can distinguish the purpose and the way it works. So those are the things I wanted to discuss about this web application security part. Perhaps some of the things I have discussed may be not very clear, but I think if you follow these slides and if you follow the tutorial I provide, you can have kind of a basic understanding, a good understanding about how this certificate works and how this public infrastructure works, and what are the importance of different algorithms and how they are used in uh, your web protocol stack. And some additional information are there, but there are not detailed information. So further reading, you can read about Tor, anonymity network, and email security using PGP. PGP is a pretty good privacy. The name that is called PGP, and PGP will give the potential to the email writer to encrypt the email from its side and allow the receiver to decrypt it from the receiver's side. So that provides a end-to-end security between the email send and receiver. So this is also based on the public key public key technology, not public key infrastructure. That you have to what you have to do is you have to generate the key pair and keep your private key in your site, and publish your PGP public key in your websites, or maybe in your name card or whatever, maybe using a phone call and whatever method. And then the person who has that your public key can use that and encrypt the messages to you, and only you can decrypt it. So general method of using these public key technology, public key method. And instant messaging privacy using OTR, off the record protocol. So these are the things you can further read in the internet and get some more knowledge. And these are the technologies you can use in your web browsers. I mentioned that HTTP everywhere, you can install that, and that means whenever you write uh, a request, it will automatically request for HTTPS version. And for your network connection, Tor or VPNs are you can use Tor browser or virtual private networks. And for email, you can use PGP. And for instant messaging, iMessage, and other things, I have not used them. Um, and also on your web server, you can use TLS protocol to protect your web traffic from your servers to your clients. So most of these lecture slides are adapted from the lecture slides of Professor Ernest Fu and Professor Douglas Stabila, and they have very good materials in the internet, some videos as well. You can follow them as well. So these are the things I wanted to discuss. So I conclude this lecture about web application security. Hope you can use this knowledge for your future. Thank you very much.